So the NOR gate is basically A plus B whole bar. Okay, now how are you guys going to do this? Let's do it quickly and take a pic and quickly post it in the group. Okay, I want something to be analyzed like this quickly. So this is your NOR circuit. Okay, quickly draw the truth table. So A, B, Z, 0, 0, 1, 1, 0, 1, 0, 1. What is the value? Quick.
One.
So this is going to be 1, 0, 0, 0. Okay, so now apply that, 0 and 1s. Now find out P1, P2, N1, N2. Now let's quickly do that. So when both are 0, 0, what happens? There is a charging path. Okay, only in that case. So output is going to be 1. Now when any one of them are 1, yeah, now so it would be kind of completely getting discharged either this way or this way. Okay, in these conditions, because any one of them are kind of say 1. Now this is going to be all discharged. Okay, so it is going to be 0. Okay, so this is how you can actually draw a circuit and analyze how it operates and all of that. Okay, now let's get into the next level. Okay, so can you guys tell me what is the output of the equation for this particular thing? So the equation for this,
B plus C.
tell me the final thing, please. Okay, go ahead. So assuming say this is going to be Z, okay, so Z is equal to
A into B plus C
A into B plus
B plus
C,
C
okay,
plus D whole bar
plus,
plus D whole
okay,
bar.
plus D and then the whole bar. Okay, so this is one answer. Anyone else?
Same answer, sir.
Okay, anyone else?
Same.
Okay,
Same
okay,
answer, sir.
okay, okay. So yeah, it's basically D, this D plus then A dot B plus C the whole bar. Okay. Now this particular thing is going to be exactly kind of opposite. So anything it is parallel here, it is going to be in series, and anything is in series, it is going to be kind of parallel. Okay. Okay. So what is our output equation for this?
A plus B into C plus D whole bar.
Hmm. Okay. Can you tell me what is it? A?
A plus B
Okay.
into C plus D whole bar.
A plus B into.
C plus D
Okay.
whole bar.
Okay. This is correct.
Z equal to A plus B into C plus D.
Okay. So Z equal to A plus B into C plus D. Okay. Anything else? There are many people. Why only few are answering? What about others? Okay, so a couple of them have answered it in the chat. Okay,
A plus B into C plus D whole bar.
okay,
First answer.
yeah, okay.
First answer,
And
sir.
first answer, okay, okay, all right. So remember this, there is no bar here in the second answer. This is basically wrong because as I told, right, it is going to be kind of bar by nature, the way the circuit is kind of formed. Okay, now this is the right answer. Okay, now let's go and take a look at some of the uh, homework part. Now I want you guys to solve whatever this, right? I want you to draw the schematic for all of this. Okay, I want you to draw the schematic for all of this. Okay, that's going to be a homework. I will copy, and I think it is already posted in the group. So I want you to draw the schematic for this whole, different bunch of problems. Now, let me tell you, for a PD engineer, this is nowhere is going to be, asked, but you knowing that is added advantage because you would be able to talk in terms of cell level. Okay, that is the main reason I'm covering the whole standard cells part. Okay, all right. Now, moving on, the next important topic is layers in VLSI. Okay, so what is this layers? What is this layers? What is this layers? Why do we need that?
to interconnect cells.
Okay, so without these layers, you cannot manufacture the chip. Okay, so let me just show you something which is gonna give you more clarity. So now I wanted to suggest a book that you should go through. Okay, so CMOS VLSI design. Okay, by Weste and Harris. Okay, so this is the book that I have gone through and to understand the basics of CMOS and all of the basic circuits and etc. Okay, and in that book, first chapter itself, okay, first chapter itself will have your D flip flop schematic. Okay, first chapter itself, you will see a DFF schematic. So I want you to understand that. Okay, and how they kind of the people design a flip flop. So whatever that we have discussed till now, it's basically basically inverter, buffer, NAND, NOR. Okay, now I want you to go one level next, higher. That is going to be your say your DFF. Okay, that would actually help you. Okay, now so go through this book. So in this book, first four chapters, ideally speaking, first four chapters. Okay, you should go through it. And let me tell you, if you don't go through it in the next 1 or 2 weeks, I can bet you will not be able to go through it next to the whole course. Okay, and let me tell you again, no equations, no solving problems. That is not what we are looking for here. You need to understand more of a concept. So the first four chapters, I have been telling this, batch after batches, and people take it light. And later, when they go for interviews, and you know, sometimes they won't even know what are the different steps that happens or are executed during the fabrication and all of that. Okay, so go through it this week or next week. After that, I would be getting into our actual physical design and then the PDK and all of that. You will not get time after that. Okay. Okay. Now coming back to this our thing, right? So where we manufacture our,
By any chance, do you have the soft copy of this?
I think it is there. We can forward it to the group. We can
Okay.
do it. No worries. Yeah. Yeah. Okay. Now, so what is this base thing? So we talked about it, right? So P substrate. Okay. Now P substrate on that we actually manufacture. Okay. Now if you look at this is your P substrate. So now I think I've showed you guys this in the past where you have a silicon comb. Okay. Now say it is kind of going to be like this. Now this would be kind of chopped. Okay. This is kind of called as a wafer. Okay. This would be chopped and it is finally you will have something like this kind of wafer. On top of this wafer, your chips would be manufactured and it is going to be kind of like this. Okay. So you will have some of good chips. Okay, and etc. So now finally this is what it is going to happen. This they would be chopping this, cutting into cutting each of them and then packing it. Okay, doing the package. Okay, now coming back to our regular thing. Now on top of this wafer, so that is nothing but your P substrate. Now they go and manufacture your N mass on directly on the P substrate. Remember, your N mass is manufactured on the P substrate. Now, how do you manufacture your PMOS? How do you manufacture your PMOS? So now remember on P substrate, it is easy to manufacture NMOS. Okay. Now to manufacture PMOS, you need something called N well. Okay. You need something called N well. Now your PMOS transistors are kind of P plus, which is being formed, and then this is kind of say gate and all of that. Now to manufacture your whole transistors or the whole chip, okay, you need different steps or different layers that you need to actually follow. Now those layers are these guys. Now if you look at the first thing is, so you get your N well manufactured. So you have your wafer, that is basically your P substrate. Now your N well gets manufactured. Now next after that, your P plus, where your PMOS gets manufactured, and then you actually go and add or kind of create that N plus impurities that would actually kind of helps in creating the NMOS. And then we talked about something called width. Now that is nothing but your oxide diffusion. Okay, so this we call it like kind of OD. That is exactly what depicts your width of the transistor. OD is what exactly the width of the transistor. And then your poly comes into picture. Poly is nothing but your the gate material. Okay, and then your contact. So if you guys remember, so you have a transistor which is kind of say like this. Now this is say source, this is your drain, and this is your gate. Now all of them are getting connected to your say power and your input, and then say your output and all of that. Now so here they have to use contact to connect your VDD to source of the transistors, and then they have to use again contact and metal to connect to your drain, and then inputs the gate. Okay, so contact is used to connect the layers. Okay, connect to the layers. Now these layers are the one which is basically we call it as a base layers. Okay, now people even call this as a FEOL, front end of line. FEOL. Now these base layers helps in fabricating or manufacturing your transistors. Okay, transistors. These base layer helps in manufacturing your transistors. Okay, now comes say if you look at right, or say transistors or say gates. Okay, now in this circuit, say for example you have a circuit like this. Okay, now to manufacture this circuit, what and all you need, so basically this is your gate. Okay, and this is your gate. Now you will manufacture these gates with the help by using these layers. Now how about this net? How do you manufacture the to manufacture or to have this nets, right, that is getting connected? So you use metal layers. Now remember, why do we use, see, remember these are all kind of base layers which are kind of different impurity addition and all of that, and we use metals. Okay, to manufacture your nets, so that your R and C values will be kind of lesser. Okay, that will bring down your net delay. Okay, so your metal 1, vr 1, metal 2. Now remember, there are multiple metals, so it is like kind of, see here, m1 and then m2, m3, so it is a kind of stack, one on another, one on another. Now to connect this m1 and m2, you have to use something called via. Okay, so you want to connect m1 and m2, you need to use via. Now say m2 and m3, you need to use via 2. Now m3 and m4, via 3. So to connect different metals, basically two metals, you need via. Now this whole thing we call it as a kind of metal layers. Now this is something we call it BEOL, back end of line as well, and this helps in manufacturing your nets. Okay, so now both of them are important, so there is nothing like, okay, you just focus only on base and then ignore metal, nothing like that. So you have to have both, completely, taking care of all the layers, looking at DRCs and certain rules and all of that. So these are all the different layers that we actually will be having in our physical design database. So you would be using them to get your layout done. Okay, so any questions here? No questions? Okay, sorry,
Contact means
sorry, contact.
contact means which type of material?
Contact is used to connect metal 1 and metal 1 with any other below layers. So let's say you want to connect your, this drain part. This is a kind of, the other side, the P plus or N plus or whatever it is, right? So you use metal 1 and, any other layer below. You want to connect anything, you need to use contact, and any metal to metal, we always use via. Okay.
Means which type of material contact?
Uh, See, it is basically a hole. See, it is basically,
Oh,
now you want to connect these two, right? What they do is they actually will have a kind of, one layer that is getting kind of manufactured, and next one, say you kind of have a insulation. So it is kind of having insulation. Now let's say you want to connect this layers, say kind of M1 and M2, which is kind of, we will have a layers which is kind of doing like this. Now what we actually do is, you actually, before manufacturing this, you actually drill this, or kind of etch. So now this will actually bring this something like this, so it's kind of via. Now so you actually, when you do a metal deposition, metallization, it gets connected. So it is kind of, now if you look at, so this layer M1 and this is kind of M2, they are kind of connected. So it is basically metal, and then you'll have some kind of dielectric, and then again you will have a metal, and then you will actually have this kind of coming in. Now you kind of etch it and then do a metallization, which would actually connect this M2 and M1. So this probably you will get, you will get a good understanding when we get into the layout portion in the tools. Okay.
yes. Okay.
Yeah.
Will you cover RDL separately or
uh what exactly are you looking for in RDL?
so? it is used at top level. So do we need separate? I mean, detailed information there, or
It is just
as
no,
part
no.
of
It
this?
is no, no. See, I would be covering. So how where we use RDL and all of that. Uh, so it would be, see, it is just one of the layer.
Sure.
Okay, so on the topmost layer where you may have a bumps and then connecting bumps to the mesh, PG mesh, and then to your IO pads and all of that. So um, that is a full chip level scope, which people may not understand, but maybe if we get a time in the end, we can actually cover that. End meaning towards the end of the batch, end of the course. Okay.
Okay.
Yeah. Okay, all right. So just go through that book and we will meet next week. And next week, what we are going to talk is more of this layout portion. So how do we draw this layout and why do we need this kind of layout? And I would be showing you some of the layouts in the tool and all of that. Okay. So different cells. Now, if you look at here, this inverter X2 and this kind of inverter X4 and all of that. Okay. And we will just try to complete this and then we will get started on the I think we will have to cover the CMOS second order effects as well. So probably in the next class we might cover uh, the second order effects and then layout, and then you guys will move on to the standard cells portion and all of that. Okay, so that is what we're going to have cover in the next week. Okay, I think that's all for the day because we are running sort of time. I think if I start anything, it will take a lot of time. So we'll stop here and we'll continue in the next class. So I'm done. If you have any questions, you can stay back and ask. Otherwise, you can leave. Okay, all
Okay.
right. Yeah. See you guys. Bye.